All right, so we just have one more piece that we need to add to section 9.5, and that is called the discriminant. The discriminant is inside the quadratic formula, which we've already seen. This is the entire quadratic formula right here, and the discriminant is the part that is just highlighted in red. So if you are ever asked to find the number of solutions or find the number of x-intercepts, you are going to use the discriminant formula, which is part of the quadratic formula. So you have learned that there are different types of graphs that you can have when you have a problem. You can have a graph that has two solutions, and that means the parabola crosses the x-axis in two different places. You also have a parabola where the vertex is on the x-axis and you only have one solution. And lastly, you could have a parabola where it never crosses the x-axis and there are no solutions. You saw in your journals today that when you do the quadratic function or formula and you get something like the negative square root, the square root of a negative number, your answer is no solution because there is no number that you can take times itself and get a negative. So when you get this in the quadratic formula, that means you have a graph like this because there is no place in which that function crosses the x-axis. Okay, so the discriminant just tells us how many solutions that we get. So this is how we're going to interpret it. So when I use the discriminant formula, b squared minus 4 times a times c, and I get that answer to be greater than 0, I'm going to have two solutions, which means that my parabola crosses the x-axis in two different places. If I get my discriminant to be equal to 0, I'm going to have one solution, which means that it crosses the x-axis in one place, and my vertex is on the x-axis. Then I also have no real solutions, and that is when I get that number to be less than 0, and my parabola is either above or it's below. So let's see how this would look. So the first thing I'm going to do is pull up an example. Let's use those examples. So we are just asked to determine the number of real solutions. I don't actually have to solve them out. I just have to figure out how many answers I would get for this parabola. So I'm just going to use the discriminant, the b squared minus 4 times a times c. Okay, well b is 8, a is 1, and c is negative 3. So 8 squared minus 4 times 1 times negative 3. 8 squared is 64. 64 minus 4 times 1 times negative 3 is negative 12, which this actually is adding. So 64 plus 12 equals 76. Now I have to interpret this. So since 76 is greater than 0, I'm going to have two solutions, which makes sense because if we think about it, this part is inside the square root of the quadratic formula. Therefore, if I have a number that's bigger than 0, I'm going to have both a positive and negative solution. No, it won't be the square root of 67, but I can't have two answers. So for B, this time I don't have everything equal to 0. So the first thing I have to do is subtract 6x, and I would get 9x squared minus 6x plus 1 equals 0. Now again, I'm just asked to determine the number of real solutions, so I'm going to use the discriminant formula, b squared minus 4 times a times c. So b would be negative 6 squared minus 4 times 9 times 1. So 6 squared is 36 minus 9 times 4 times 1 is 36. So that equals 0. So since my answer is 0 and 0 is equal to 0, I will have one solution. And again, if we think about this, I'm taking the square root of 0. So I'm only going to have one solution because there is not a negative 0. I'm just going to get the positive of it. So that makes sense why I would only get one solution. Now, an example of when you would get no solutions would be like number 8. So again, I'm just asked to determine the number of real solutions. So I'm going to use the b squared minus 4 times a times c. Well, b, again, I'm going to have to get everything equal to 0. So I would add 1, 6x squared plus 2x plus 1 equals 0. So b would be 2, so I would have 2 squared minus 4 times 6 times 1. So 4 minus 24, which gives me negative 20. And since I can't take the square root of, since negative 20, is less than 0, I have no solutions. And again, that makes sense because this b squared minus 4ac is inside the square root of the quadratic formula. So there is no way where I can get the square root of a negative number. Therefore, my answer is no solutions. The next set of examples, I'm not going to go through step by step because it's the exact same thing. It just has a little different wording on the instructions. It says find the number of x-intercepts. Well, your solutions are your x-intercepts. So the number of x-intercepts is the same thing as the number of solutions. I'm still going to use the b squared minus 4 times a times c for those ones as well. Okay? This last set of examples, we kind of already talked about the last time I had you in class. There are several different ways that we can solve.
Mr. Helkeman, study lab 9th period, needs to report.
There are several different ways that you can solve quadratic formulas, but the fastest way is factoring. So you always want to see if you could factor it first, or however the question is written. So like this one, you'd probably use completing the square, because when you complete the square, you need a binomial, and it is already in the binomial form. For B, I would use the quadratic formula, because I need to get rid of this 2, but 13 doesn't easily divide by 2. Therefore, if I use complete the square, it's going to get messy answers. So that's when I would use the quadratic formula. If you use completing the square, you will get the same answer. And then the last one, I would use factoring, because I can take factors of 12 that equal 8. And that's the fastest method. So I will probably not give you problems that say choose the best method. I will tell you specifically what method I want you to use. But I just want you to know that there are different methods. You'll get the same answer. Some of them are just easier to obtain than others.